Or is it still thinking? It is recording. Right. So on Monday, we look at this problem, just a quick recap. Okay. We did from the element to Mohr circle. So this question, just to recall, is we want to find at 60 degrees. Okay, 60 degrees we highlight in yellow when the element is rotate counterclockwise. Okay. So we found our point X. Okay, our point X is down here. And then we found our point Y. Then we calculated, okay, we calculated our stress Y60. Okay, we also calculate our stress X60. And we calculated our shear. Okay, so those are the value. Okay, so what I'm going to do now, because there is a big mess, okay, so I'm going to make it not so messy now. So this is the element that we are dealing with. And we were told that we have to orientate this. Okay, we're going to rotate this from point Y. We're going to rotate this counterclockwise, and we call this Y60. Okay. If you were to rotate from X, right, it's going to be going in a clockwise direction, X30. Okay. So now I'm going to sketch our Mohr circle. Okay. A quick sketch. Yeah, I'll do a very quick sketch. And we did find out that this is how the circle look like. Again, this is a sketch of the circle, okay? I have to sketch it again. And we found out that, oh, it's lopsided. Apologies. Okay, so this is just a sketch. So this is normal stress, shearing stress, element rotate clockwise, rotate anti-clockwise. And then from last lecture, we find where is our point X and where is our point Y. So this is our X. Okay, hold on, I have to roughly guess where is the center of the circle. Bear with me, okay? I'm sketching now. Okay. You can ignore what I'm doing now, okay? I'm just finding the center. Hi. Wait, can I do this? Go away. Ah, it works. So we found out that this is our X. And over here, this is our Y. Okay. And on that, this is the orientation of our element. Okay. By knowing this, that this is our Y. And over here, this is our X. And then we rotate by 120 degrees anti-clockwise. Okay, so this is just a sketch, okay? And we know that this is our Y60, and directly opposite, this is our X60, okay? So what we have just done is we have rotate the element, okay, anti-clockwise, And the anti-clockwise rotation now, we know that this is what? 60 degrees. And we found our coordinate. Okay, we found our coordinate because at the end of the day, you are looking at normal stress and shear stress. We found our coordinate, and the coordinate we found y60 is minus 11.514. Okay, so let me cheat a bit. Okay, let me cheat a bit. Why I say cheat a bit? Because this has to be in the minus side. Okay, it's just a sketch. Okay, just a sketch. Okay, so this is going this way. Okay, still the same. Okay, so we know that this over here is at minus 11.514. And then we are aware that the shear is 550.851. On the other side, we know that it is equal to minus 298.486 and 550 minus 550.851. Okay. So now we are going to draw the element at 60 degrees. Okay, so I'm going to sketch our usual element. Okay. And then we are going to have another element that we are going to rotate by 60 degrees. Okay, so this is the other element. And now the other element is going to rotate by, this is 45 by 60 degrees. Okay. So we know, right, what we know, like what I told you before, right? You draw a line down here. This represents your Y. Okay. And then you draw a line down here. Or you draw a line down here. This represents your X. Okay. And we know that this is going to rotate, and this is known as your Y60. Okay. By looking at your Y60, we know that over here, we have a compression of 11.514. And if this side is 11.514, if we rotate by 90 degrees on element, right, we call this surface over here, now is your what? X60. So when you look at X60, you also have your compression going by 298.486, right? So your Y60 is over here. You can rotate clockwise or anti-clockwise, does not matter. It's going to be 90 degrees. You get your diameter point 298.486. Okay. So now the confusing part is the shear. We know the shear will be what? 550.851 and 550.851. What we are interested in the terms of shear is the rotation of the what? Of the element. I repeat again, is the rotation of the element. When this is the case, Y60, the element will rotate in the what? Clockwise direction. I repeat again, Y60 is going to generate a clockwise direction. In order to generate a clockwise direction, this force has to be going which way? Yes or no? The shear have to make the element rotate in the what? Clockwise direction if we put a pin in the center. Make sense? Right? We did this last week. Okay, I'm going to do it again. Then the next thing we're going to focus is we are going to focus on X60. Okay, now the X60 is going to go anti-clockwise. In order to go anti-clockwise, we know that this arrow has to go this way. With that, we know that this value will be 550.851. Make sense? Okay, so what we've just done is you have done something fantastic. Okay, we went from Mohr circle, we went from element, go into Mohr circle, from Mohr circle, bring it back into the element. Okay, and that is important because only when you are in the element, you're in the real world. Are we clear? I'm not wiping it out yet. Be clear? Or not, Mohr circle don't mean anything to you at all. Mean anything. Be clear? Okay. Okay. So that is how 2D Mohr circle work. Okay. The next thing that I'm going to introduce to you is 3D Mohr circle. And 3D Mohr circle is not a sphere. It's just Mohr circle with 3 circles. Are we clear? Okay. 3D Mohr circle is a sphere. I will not be teaching it. Okay. So let's look at 3D Mohr circle now. Okay. How many of you are still as confused as hell regarding 2D Mohr circle? It is normal. You have not done homework yet. Okay, once you start doing the homework, you'll be fine. Are we clear? Okay, do your homework and build the confidence. Are we clear? Now, it's confusing. It's normal because your brain is all about math. We clear? Okay, so don't panic yet. When do you panic? Huh? Wait, when do you panic? When? Again? No. You only panic. You should really panic when I panic. Are we clear? I'm not panicking yet. Okay, so you should not panic. Are we clear? When you panic, when I pee my pants in front of you, you panic. Are we clear? If not, you don't panic. Okay? If you panic, there's something wrong with you. Okay? Don't panic. Take it easy. Breathe. Okay. So the next thing that we're going to do now, okay, the next thing that we are going to do now is what we call 3D Mohr circle. Again, 3D Mohr circle is not more difficult than 2D Mohr circle. In fact, 2D Mohr circle is everything. Once you know 2D Mohr circle, 3D Mohr circle is Mickey Mouse. Okay, so let's go. Let's dive into 3D Mohr circle. Now, in 3D Mohr circle, okay, let's draw a 3D element first. Okay, so this element has stresses in the x direction, y direction, and z direction. By now, you should be very, very familiar what plane they are. Okay, so over here, this is known as your XY plane or capital, I will do capital XY, okay? So this is your XY plane, okay? And we know this is known as your in plane. Why is your in plane? It has the largest surface area, okay? The next one, the next surface we're going to have, this is known as our YZ plane. And on your YZ plane, this is known as your out of plane. Okay. And then the third one over here, This is known as your XZ plane. Again, this is your out of plane.